you could say they usually orbit each other. So this is the original one we were looking at a moment ago. Now you could see it's a bit different than this orbit. They're both binary orbits, but they're slightly different. Look at this. When they get closer, they speed up. Why is that? Because of the electromagnetic energy that is coming from each star. Do you know when they send certain space probes out, for example, they're sending this stuff to Pluto, they send it in the opposite direction first to go around the planet Venus. Some even send it to go around the sun, so that when it goes around the planet or the sun, it gets this boost of energy that pushes it out into deeper space. That's what they say, NASA. Basically, talk to me.
How can you even get close to this?
Well, this is the probe that they would have created, would have been developed just for that purpose, really. So what happens here, as these stars are getting close to each other, the energy pushes them back out. Watch it. And it pushes them back out. And it helps them to keep their momentum. Now, this is a bit different. This has one space. It doesn't slow down. It doesn't speed up. It's just going around this bigger star. And this star itself has a pivot point. So you could see that there's a difference within these two different binary systems. They're both binary star systems, but they're still a bit different. Okay. Can you read that here for me? Some fun facts, as they call it.
Yeah. Virtually all elements heavier than hydrogen and helium were produced in stars.
Here, that's all elements heavier than hydrogen and helium were produced in stars. Well over 2/3 of all stars are dim red dwarfs. So more than half of all the stars that we see are dim red dwarfs. In addition, listen to this, in addition, most of these are single stars. That is, they have no companion stars. So in reality, most of the stars that we look at are really stars. Meaning that they're just one star. Oh, okay, I get it. But some of them are more than one stars. For example, most bright stars exist as components of binary or multiple star systems. So we're dealing with more than just two. Multiple star systems. Before we go into any multiple star system, let's just look at some other type of binary star systems, because I find this quite interesting. Note that a pair of stars can be substituted, for a single star in another system to form triple stars, quadruple stars, and so on. Because you have 5-star systems and you have a 6-star system. And before we are done with this class today, we are going to look at a 6-star system. This is some serious stuff. What do you call them? The sextuple star system. That is when you have 6 stars, like in the star known as Castor, Gemini. We look at Castor and we think it's one bright star. That's 6 stars. But we're going to look at that before we leave. Now you could see now this is another binary star system, but it's different than these. This creates somewhat of a subset with a pivot point in between, and they both here subset and cross over the pivot point. This has a pivot point basically at the edge of the greater star. But now let's look at these two examples. Another pivot point where you obviously have that center of electromagnetic energy, that gravitational center. And the stars, which are basically the same size, are at a similar distance, and they're just going around keeping a constant pace and a constant distance from each other. You get that? Constant means the same pace. So you're moving at 5 miles an hour, you move at 5 miles an hour for a long time. You don't slow down, you don't speed up. Constant. So that's, you just have this constant rotation around this center point and a constant distance. For example, these do not have a constant distance. They're way over here. Now they get close, then they go far, then they get close, then they go further away from each other. That's not a constant distance. These keep a constant distance as well. But as I said, these stars here are at a perfect distance from each other, exact Whatever the distance from here to the center point is the same distance as it relates to the other star.
Yep, indeed.
Indeed. Now, if you look at this one reminds us of the atom. If you notice, they have two different tracks that they're running on here. You're saying something?
Neutrons and the electrons.
Just like how we have the neutrons and the electrons. In
If
fact,
there was a third one there, I would name it proton.
the protons. Basically, the atom is just like the galaxy and the planetary system. They're all the same. So what you are looking at here, yes, you have another binary system, but you will notice that the larger star is closer. It has a lot to do with the size. The larger star, the sun is bigger than all the planets. The larger star is closer to the center here. And the smaller one is on another track, but they're basically both going around the center. So just take a look at them. You could see the difference in the different types of binary star systems. Okay, now what we're going to do here before we leave, we're going to take an example or take a look at a 6-star system. Let us just press that for you. I'm going to share it with you if you're not seeing it. And this 6-star system, again, as I just mentioned, is Castor. So this is the constellation of Gemini. Gemini is the water carrier, right?
Nope.
No.
Oh, Gemini is a lion. Gemini, you can see a lion here. No, not a lion?
Gemini is it's supposed to be two twins.
The twins, right.
But in reality, it's male and female.
Male and female. This is the male and this is the female. Castor and Pollux. The female is the one with the more hips. Now, Castor, which is a Greek name too, this star Castor is made up of 1, 2, 3, 4, 5, 8 stars.
6.
Oh, just want to make sure you're paying attention. 6 stars. This is the sun over here. 6 stars that make up.
Irrelevant.
Yeah, 6 stars that make up Castor. Look, so what this is just showing you an expansion. So you have Castor C in this orbit, and Castor C is made up of 2, Castor CA and Castor CB. So Castor C is still made up of 2 stars. Then you have Castor B, Castor A1 and AB, and all of these, 6 of them in all. That gives you this one bright looking star. So that means if we were to fly to Castor, get out of the way, the closer we get, we will see this one star breaking up into 2, into 3, and eventually into 6. Not only if we can, we did it already. We already touched this in one of our previous classes. I'm sure you can remember when we were looking at the different stars that are in this one star system known as Castor. So as you can see, this is deeper than just looking up in the sky and twinkle, twinkle, little star. All right, good. So I hope you full enjoyed this session here today, looking at the different star systems. We kind of highlighted the binary star systems